This is the first of several videos on stoichiometry, and this one is on the most basic form of stoichiometry, which is mole-to-mole stoichiometry. And we need to start by defining things. Stoichiometry comes from two Greek words, stoichio or element, metry and measurement. And it is essentially measuring the ratio of chemicals involved in a reaction, and it is a mole ratio. Stoichiometry questions, if you break them down, come down to being if-then questions. If I have this much of reactant Z, then how much reactant A is needed? If I want to make this much of product D, then how much of reactant Q do I need? If-then. Stoichiometry equals mole ratio. This cannot be stressed enough. Stoichiometry equals mole ratio. 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 It cannot be stressed enough. Mole ratios come from properly balanced chemical equations. You set the ratio up using the coefficients of the chemicals in the if-then statement. There are 4 steps to mole stoichiometry. First, you write out a balanced chemical equation. Secondly, figure out which 2 chemicals you're interested in, the ones in the if-then statement. Set up your mole ratio. I recommend you put the unknown in the numerator, as it will prevent math errors. Then simply solve for the unknown. And if you follow the 4 steps, you can hit the easy button. So here is an example. Ammonia will react with oxygen. It makes water and nitrogen monoxide. I start with 1.6 moles of ammonia, so how much oxygen is needed to complete the reaction? Follow the steps. Write out the balanced chemical equation. This is the balanced chemical equation. Identify which 2 chemicals you're interested in. If I have 1.6 moles of ammonia, so ammonia is my if statement. Then, how many moles of oxygen are needed? So oxygen is my then. Now I'm going to set up the mole ratio with the unknown in the numerator. I'm comparing oxygen and ammonia, so this would be the ratio based on the coefficients. I set up the equivalent statement using the given data. Now I'm just going to simply solve for the unknown. I'm going to cross multiply and divide, and when I do that, I get 2 moles of oxygen is required if I have 1.6 moles of ammonia. So now one for you to do. Pentane is going to combust with oxygen, and it will produce carbon dioxide in water. You start with 4.5 moles of pentane. It's reacted with an excess of oxygen, so you have more than enough oxygen. How many moles of water should be produced? Stop, figure it out, come back, check your answer, and then I'll walk you through it. Go. And the answer is 22.5 moles of water should be produced. Step 1, write out the balanced chemical reaction. This is the balanced chemical equation. Determine which 2 chemicals make up the if-then statement. Well, if I have 4.5 moles of pentane, so pentane is the if, then how many moles of water will be produced? So water is the then. Set up the mole ratio with the unknown in the numerator. The unknown is the water, so my ratio is 10 to 2. Make the equivalent statement using the data we're given, something over 4.5 pentane. Solve for the unknown, so you're going to cross multiply and divide. And when you do the math, you get 22.5 moles of water should be produced. That's all there is to mole stoichiometry. So to review, stoichiometry equals mole ratios. No, I'm not going to keep repeating that right now. Mole ratios come from properly balanced chemical equations, and the problems can be seen as an if-then statement. If I have this much of something, then how much of the other do I need? If I have this much of something, then how much can I make? From mole to mole stoichiometry, there are 4 steps. Write out the balanced chemical equation. Determine which 2 chemicals make up the if-then statement. Set up the mole ratio with the unknown in the numerator. And then solve the sucker. That's it. Unfortunately, we tend not to measure things out in moles. We measure them out in grams. We talk about pressure and volume, temperature for gases, or molarity for solutions. In the next video, we're going to show how you get from those states into moles to do your mole-to-mole conversions.